Okay, so hello everyone. Today we are solving one of the most famous interview questions, which is LeetCode 31 next permutation. So it's a medium level question, but I would rate it as a medium hard problem because it's a new pattern and like most of the people cannot do it in one go. They have to seek the solution, they have to refer to the solutions to solve this. So, like many people simply remember the four steps to complete this question, but in this video, we will understand why every step exists. And once you understand the intuition, you will never have to memorize the algorithm again. So, let's find out what is the problem exactly. So, basically, we are given an array representing a permutation. So, our task is to rearrange it into the next greater permutation. So, what this word means, this lexicographically, we will refer to it when we will be on the whiteboard. But till then, just remember this. And basically, what this means is like if we have these one array, so we will write all the permutations for it. We will have all the permutations. These are the permutation, like how they can be arranged, and from this we will have to arrange them lexicographically, which is basically a dictionary format, or we can say in a sorted manner, like 1 2 3. If we say it's a number, so 1 2 3 is smaller than, we can say 1 3 2. So yes, after 1 2 3 it will come 1 3 2. So this is the like order in which they are sorted, or lexicographically greater permutation if we say. So this is the main problem, and what we have to find out is we have to find the immediate next permutation to this 1 2 3, not the immediate next permutation, but a proper lexicographically greater permutation which is in the sorted manner. So let's move to the whiteboard and let's see how we can solve this. So suppose the array is this, as we saw here, 1 2 3. So these are the permutations that are possible. So we can write it any, like in any random order also, but what this lexicographically order means that they are sorted, like 1 2 3, then 1 3 2, then 2 1 3, like in a sorted manner. So what we have to find is we have to find if the in the question we will give this array as input, so the answer would be 1 3 2. If we give 2 1 3 as input, then answer will be 2 3 1. So this is the basic intuition. And if the question gives input as 3 to 1, then we have to give the array as 1 2 3 in the answer, because it has no next permutation. So we will get back to the first. So the brute force approach that we can think of is that we can generate like every permutation that is possible. We can generate it recursively, and then we can sort it with using a like STL template, sort template. And then if the array has an element, so number of permutation becomes n factorial. Like if we have n, so it becomes n factorial, the total number of permutations. Of course, we studied in mathematics. So if all of them, generating all of them, sorting them, like if it is like 10 numbers, so the factorial would be like 3.6 million permutations. So it is not practically possible. So it will not be like done in it is not optimal, of course, because it will take n into n factorial. Basically the time complexity will be n into n factorial, which is far too slow. So can we do it better? Okay, so let's take an example first. Let me erase this. So we will take good time for this because it's a heavy problem and we need time to understand this. We will get an intuition, then only we can solve this. So let us say we will take example 1 2 7 4 3 1. Okay, so let's say this is a number. So our goal is not to create a completely different permutation, we only want the next one. So that means we should make the smallest possible increase. Now ask yourself, where should we change the array? Towards the left or towards the right? Suppose we change the very first number. Suppose like we change this 1 to 2. So it creates like a huge jump to a number, like it was 1 lakh but now it is 2 lakh. So this is not a good idea. If we have to change it to a like the smallest increase, then what we have to do is we will change this 1 to 2. This is the basic increase that we can do, right? So yes, this is the intuition that why we will move from right to left while doing the optimal approach, while traversing in the number. So that's why it is like the we will have to like change the right most. No, we have to take the longest prefix, if we say in technical terms, longest prefix to like change, because if we change the first number it will create a huge jump. So if it was 1, we can make it 2 and it will be a small increase. Okay, so let's move from right to left. Okay, if we say like, okay, so this was that we change it, Okay, this was an intuition that we change the number. But if we are not allowed to change the number, what we can do is, because we have to make permutations, right? So if we take only one, then it has only one permutation, we cannot change anything, so it will be the same, 1 2 4 3 1. But if we take 3 and 1 together, yes, then also if we like change the positions, then 13 will come, and 13 is smaller than 31, so yes, there is no use, it will not increase. Now if we take 4 3 1, then what we can do is, we can write, we can say, just a sec, what we can write, if we take 4 3 1, then what we can write, 1 4 3 or 3 4 1, anything we can write, but 4 3 1 is still the greatest. Okay, so that is also of no use. So are you getting the intuition? What we have to do is, like, if it is 7, then also if we like make multiple permutations to this, then it will be of no use. But if we take these 2 7 4 3 1, if we take these, then see, 2 7 4 3 1. But if we take 7 here, what if we take 7 here, then it will be greater number, straightforward. But listen, 7, if we take 7, then it will be like still a huge jump, no? But if we take 7, then it will be 7 2 4 3 1, right? It will be 72,000. It's 27,000 right now. But if we want right next, like immediate next, then what we have to do is, from these 7 4 3 2 7 4 3 1, we'll have to take the smallest, but yet greater than 2, of course, because we will have to like take the greater next greater element, or we can say number. So yes, from 7 4 3 1, we will have to take greater than 2, but smallest in these, that is greater than 2. So greater than 2 are 3 4 and 7, but smallest of them is 3. So if we write here, now you will get the intuition. If we change, like in place of 2, if we write 3 7 4 2 1, so yes, this is the next greater permutation, if we can say. Yes, this is the next greater permutation, because we took this 3, and but this is not, still not, I guess, no, yeah, this is still not the right permutation, because till now we have only like chosen this index. But if we want to make it a proper next permutation, then we have to make this also like smallest increase we want, right? So yes, for smallest increase we will have to sort this. If we sort this, what will this value become? Let's see, then you will get the idea. This will become 1 2 4 7. So yes, this was 7,000 before, now it is 1,000, we can say. Like 1,31,000 it was before, 1,37,000. Yes, smaller is this one only. So this is the immediate next permutation to this number. So you got the point. The first step we did was, we started traversing from the right side. Okay, we started traversing from right side, then we find and find and find. What we find? 1 was smaller than 3, no use. 3 was smaller than 4, no use. 4 was smaller than 7, no use. 7 was greater than 2, it is of use, because if we replace 2 by 7 or any number in the right side, then it will like become like easier for us to make the next permutation. So we can break it here. What this means is, we have to change the 2 value first. We have to change this index, because we have to like make immediate greater. If we did change something right to it, then it was like smaller or the same number. But if we change it from here, it will change, because in right side we have greater numbers. So now what we have to find is, we have to make it the smallest increase, not the highest increase or the medium increase. We have to make it the smallest increase. So to make the smallest increase, we have to find the smallest element. Okay, so the greater element than 2, but smallest in all of them. So the greater there were 3 4 and 7, but the smallest of them was 3. So we'll replace 2 by 3, and after replacing it, we just have to sort this part, so that it will become in the like the smallest number, because 7 4 2 1 is still high, but if we make it 1 2 4 7, it became the smallest number. So this was the basic idea. And the data structures we will be using is basically, we can use if we do not need an extra data structure, of course, we can use only the vector that is given to us, and we can change it like for our convenience. So this was the idea of the optimal approach. Now we will try to code it. So yes, now we'll code it. Okay, so we are back at our LeetCode. Now we have the idea how we are going to solve this. Now we'll try to code it, because this is the, of course, the most important part, to code it, because to understand it is much easier than to like code it really. So yes, we need significant time to code it and understand what the code is doing. So first of all, what we need, it's not necessary, but yes, we can store the size into a variable, the size of the array. This is the first step. So after that, what we talked about is, let's get back to the whiteboard. What we talked about is, first of all, we will like find the index where we can replace the things, right? The index where it becomes lesser, like 2 was lesser than 7. So yes, we will find where it is happening. So we will find that point. And how we will find that point? Let's come back here. Now you will understand. We will start the loop from the last, as we talked about, because we saw the reason also why we are doing it, the intuition. So yes, we will start from the left. Why we are starting from n-2? Because we need to compare the last two also. So yes, it is necessary, but then it will like go out of bounds if we start from I of n. So yes, we will start from n-2 so that we can compare the last two also. Okay, so this will happen till it becomes 0. It comes to the first index. It will write minus minus. Now the condition was C. Let's move to the whiteboard. The condition was, we are coming from this side. Okay, we are coming from this side, and our I is here. Let's say I is here in the loop. Then when we have to stop? We have to stop when this ith index number becomes smaller than I plus 1, right? Easy, right? When we have to stop? When this ith index becomes less than I plus 1 index. So to store it, let's get back to LeetCode first. To store it, what we have to do is, so condition is when nums of I becomes less than nums of I plus 1. Okay, when this happens, what we have to do is, we have to store it somewhere, right? So to store the index, what we can do is we can declare a variable here, pivot, and we can give it -1 for now, because we have to store it. And yes, because why we are going to -1, because there can be a case on the whiteboard we can see. No, on LeetCode we can also see. Just a sec. Yep. So what can be the case? This, if we are given 3 to 1. Okay, so there is no ith index where we will get it is less than I plus 1, because 3 is greater, 2 is greater. Yep. So in this case, what we had to do is, see here in example also it is given, if 3 to 1 is there, then we have to give the output as 1 to 3. So we will just have to reverse it and give the output. So that's why we are taking it -1, that if this condition does not satisfies, then we can use this variable as our the reversing part. Okay, for the reversing part. So if this condition satisfies, then it's easy. What we have to do is just store it in the pivot so that we can use it afterwards. Then we can break the loop. Then you do not have to go to the left side more and more. Now we can say if the pivot is still -1, which means that we did not find any element that is lesser than the right element, then what we have to do, then we just have to reverse the array, and that would be our answer. Then we will return it. So it will be yup. So this is the syntax. I'm assuming that you know the STL, basic STL part. So yes, then we will return. We do not have to go forward, right? So now what we have to do is, we found the pivot. Now what we have to do is, we have to find, let's get back to the whiteboard. Now what we had to do is, we have to find in the right side of 2 that what is the best candidate to replace it, and what would be it? The smallest part, the smallest but greater than 2. the smallest but greater than 2. So this is the intuition. Get back to the LeetCode part. What we have to do is we will again run a loop, and this time we will run it from n-1 because we want to compare each and every element. We do not have to compare two elements. So yes, we have to compare two elements, but one element is at this place only. We do not have to move the pivot, right? We don't have to move the pivot. So yep, so now this will also run till 0, and it will also decrement. And here what will be the condition? It will be that if at any point nums of I is, we say, lesser than, oh okay, my bad, nums of I is, greater than, because 3 was greater than, right? So if any time it gets, the iterator element gets greater than the pivot element, that is 2, so then what we have to do is nums pivot, then what we have to do is that we will basically swap it, right? We are using STL. We will swap it, swap the elements. It will replace 2 by 3, that as we discussed, right? So yep, this was the condition, and then we do not have to move forward, then we can break it. So okay, so this was the part, and then what was the last part we discussed about? The last part was that we at final reversed all the right side elements so that we get the smallest number from them. So at last what we will do is we will reverse. From where we will reverse? We will reverse from the the right element of pivot till the end. So how we can write it is that from the begin you add till pivot, and in that also you add +1 because we have to move from the right element to the pivot, and till the end you can do it. Yep. So this is the last part that we have to do. So if we try and run it, will it give the right answer? So yeah, this was the optimal approach, right? The boot we discussed about was not even possible because it has a time complexity which is practically not even possible. It is not of n square, it is of n into n factorial, so it is practically not possible to work with. So yes, this was all about this optimal approach. Now if we discuss about the time complexity of this approach, so it would be we are not using any nested loops, so there are individual loops here. If 4 and 4, so yes, of n will be the time complexity for this, and the space complexity will be of 1 because we are not using an extra data structure. So yes, that's all for today. This was a hard problem. I would not say it was an easy one to tackle with. So yep, it's necessary to consider the solutions for this. So yep, this was all about, and if you are able to solve this now, then you can solve any vector problem if it is of this level, because this is a hard problem, not a medium problem, of course. So yeah, instead of memorizing find pivot, find successor, swap, reverse, you just remember the intuition that I told you as on the whiteboard. You just remember the intuition that I told you, and you will be okay with it. So yes, if this explanation helped you, consider subscribing for more DSA and interview preparation videos. See you in the next one. Thank you so much.